Chain rule. The chain rule is used when you have basically a composition of functions, meaning one function within another function. We really have that going on here because we have the outer function, which is your sine function, and you have your inner function, which is 2 times x. Now, if we go ahead and graph our function and graph the derivative in our y equals, this is what you would type into your y equals on a TI-83 or a TI-84. The end deriv here for your derivative you get from hitting your math and going down to number 8. When you go ahead and graph that on your normal trig function window, and by the way, you need to be in the radian mode, we get this graph over here. Well, you should realize that the lower one here is your normal sine function. Your derivative would be the one that goes farther up and farther down. So, instead of just being your cosine like you might anticipate of 2x, it's like twice as tall as it should be. So where does that extra 2 come from? Because it's really twice as tall. And it's really part of the chain rule. Yes, your derivative is the cosine of 2x, but then it's multiplied by 2. That extra 2 comes from being the derivative of the inside. The derivative of the inside function is 2x. Derivative of 2x is 2. So it really simplifies down to the 2 cosine 2x. So the extra 2 in front comes from the derivative of the inside, which is 2x. Your chain rule can be represented in different ways. One way is with dy, dx, dy, du, du, dx. It can also be represented in function notation, and that's what we have right here. Depending upon the context that you're dealing with, you may be wanting to use one or the other. But they both really mean differentiate the outside function, then multiply it by the derivative of the inside function. So derivative of the outside times the derivative of the inside. So here we have really two functions. You have your outside function, the sine, then you have your inside function. So what you want to do is the derivative of the outside, derivative of your sine is cosine. You don't do anything to the inside at first. So the derivative of your sine is this cosine. You just bring the inside down. You now got to multiply it by the derivative of the inside, which is that cosine of x. And you should remember the derivative of cosine is negative sine. All we're going to do here is just a little bit of simplification. I'm going to just move that negative sign in the front because then I can write it with one set of fewer parentheses. So now we're looking at the sine squared of x. You need to remember that sine squared of x really means sine of x all squared. Well, here we have really a composition of functions again. We have an outside function, which is your squaring function, and then you have your inside function. So when we're working this out, we need to do the derivative of the outside. So the derivative of the squaring means you put your exponent in front, decrease your exponent by 1. So that's the derivative of the outside. We now got to multiply that by the derivative of the inside. The inside is that sine. Derivative of sine is cosine. Well, we don't really need the parentheses raised to the first power, so we just get this. This is your answer, but however, you should remember from your trig class that this is your double angle sine formula, so we're going to rewrite it as this. So here, we have this. Remember, you may want to have this written as the cosine of x all to the fifth power, realizing once again you have an outside function of raising it to the fifth power and an inside function of your cosine of x. So you go outside, derivative of that power to the, or something to the fifth power, put the 5 in front, decrease your exponent by 1, because remember this would be cosine in parentheses all to the fourth, which shorthand way is written this way, times the derivative of the inside derivative of cosine is just normal negative sine. Then just simplify it a little bit to kind of rewrite this without the set of parentheses, gives you a negative 5 sine of x cosine to the fourth of x. Now, when we look at this one over here, we rewrite this. We have our cubing. We have our sine function. And we have our doubling function. So we really have composition of 3 functions here. So we got to work from the outside in and use the chain rule multiple times. So we got to do the derivative of the green, which is the cubing. So put the cube in front, decrease your exponent by 1. So you just keep the inside the same, but decrease your exponent by 1 to the 2. Now you got to do the derivative of the blue. Well, the derivative of sine is cosine, so it's a cosine of your 2x. Now you got to do the derivative of the inside, which is 2x. Derivative of 2x is just 2. Then a little bit of simplification. The 2 times the 3 is 6. A cosine of 2x, a sine squared of 2x. We have our outside function here once again. That's raising it to the 1/2 power. We have our inside function. So we do derivative of the outside times the derivative of the inside. Put the 1/2 in front. Decrease the exponent by 1/2. Multiply it by the derivative of the inside. Your 2 here undoes the 1/2 in front. Negative exponent puts it down in the bottom, becomes a positive exponent. So then you could also write it with the root. Either one of these last two would be acceptable. Looking at the next one over here, we have our outside function, which is raising it to the 5th power. And then you have your inside function, which is a fraction. So you got to do the derivative of the outside, put the 5 in front, decrease the exponent by 1. Now you got to multiply it by the derivative of this inside part. Well, that's just a quotient, so you got to do the quotient rule on that. Derivative of the top times the bottom minus the top times the derivative of the bottom. Then it's got to be all over the bottom squared. So the first part doesn't change. Second part, you simplify the top, you get a 2. Apply the 4th power to each part of your fraction here. 4th power in the top, 4th power in the bottom. The 10 comes from your 5 times your 2. Then we could write it as one fraction here, a 10. X minus 1 to the 4th. On the bottom, you got two things that are the same, so you got to add your exponents when you multiply them.